Hello everyone, myself Dr. Krunal Bhavsar, working as a coordinator in S.Patel College of Arts and Science, BCA Self-Finance course, Bilimora, affiliated to Veer Narmad South Gujarat University, Surat, and managed by Bilimora Vibhag Kelavani Mandal Bilimora. Now today I am going to talk with you a software engineering unit number 1 introduction part. This presentation is especially useful for SYBCA semester 3rd software engineering 1. This is introduction to software. What is software? Software is a set of instructions to acquire inputs and to manipulate them to produce the desired output in terms of functions and performance as determined by the user of the software. It also includes a set of documents such as the software manual meant for user to understand the software system. In short, software. Software is instruction computer programs that when executed provides desired function and performance. It's taking the input from input device, it will be process them and it will be giving a desired output. So it is a software. Software, it's a one kind of program. We can install it and we can use it. Software engineering. Software engineering is a layered technology. Software engineering is the application of systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software. Now, some of the goal of software engineering: to increase software productivity and quality, to effectively control software schedule and planning, to reduce the cost of software development, to meet the customer needs and requirements, to enhance the conduction of software engineering process, to improve the current software engineering practice, to support the engineering's activity in a systematic and efficient manner. Classification of a software: it bases two classes are there. First is generic software, second is a customized software. Generic software, that means, is designed for broad customer market whose requirements are very common, fairly stable and well understood by the software engineer. So best example is Word, Excel and PowerPoint. This is the office suite, all customers are working for them. Customized software is developed for a customer where domain, environment and requirements are being unique to that customer and cannot be satisfied by generic products. That means it's a own software. Whenever we are working on that shopping mall, then own softwares are there. That is a customized software. What is good software? Software has number of attributes which devise whether it is a good or bad. The definition of good software changes with the person who evaluates it. The software is required by the customer, used by the end user of the organizations and developed by a software engineer. Each one will evaluate the different attributes differentially in order to decide whether the software is good or not. Whenever we can buy any software like antivirus and we can install in our system, and if its precautions are not work, so that is a bad software and they are evaluate the virus and it will be remove the virus from that system. So it is a good software example. What are the attributes of good software? The software should deliver the required functionality and performance to the user and should be maintainable, dependable, and usable. Now let us talk regarding maintainability. Software must evolve to meet changing needs. That means it is a upgradation part of maintenance part. Dependability, software must be trustworthy. It is a trust oriented software. Efficiency, software should not make wasteful use of the system resources. It is not occupy much memory whenever software is run. That is a concept of efficiency. And usability, software must be usable by the user for which it is was been designed. Software characteristics, software has a dual role. It is a product but also a vehicle for delivering a products. Software is a logical rather than physical system elements. Whatever the hardware device we can touch physically like keyboard, mouse and screen, but software we can't touch. It is a logical things are programming. Software has characteristics that differ considerably from those of hardware. Software is a developed or engineered. It is not manufactured in the classical sense. Software doesn't wear out. Most software is custom built rather than being assembled from existing components. Software characteristics. First one, software is developed or engineered. It is not manufacturing in the classical sense. Although some similarities exist between software development and hardware manufacture. The two activities are fundamentally different. In both activity, high quality is achieved through good design and the construction of a product required, but the approaches are different. Software costs are constant in engineering. This means that software projects cannot be managed as if they were manufacturing project. It is not working just like a manufacturing process. Just like one of the example, if you are manufacturing one of the medicine for people, so it's not a manufacturing part, it's only develop and engineering part in a software side. Next, software doesn't wear out. It often called the bathtub crew indicates that hardware exhibits relatively high failure rates early in its life. As time passes, however, the failure rate rise again as a hardware component suffer from the cumulative effect of dust, vibration, abuses, temperature, extreme, and many of the other environmental maladies. Stated simply, the hardware being to wear out. That means what? Hardware it is goes out whenever it is failure, but software it is maintained and software it will be updated and software we can changing the programming and we can use it. That is a possible in software side, but if the hardware is failure we can't use it. We can just remove it from that our system. A failure rate for hardware. This is the failure rate curve for software should be taken from the idealized curve. So basically on that y-axis the failure rates are there and then x-axis that is your timings are there. Now let's check. This is your curve. Just like first of all, whenever we can purchase any system, that time the system is are going definitely fine. Then after whenever the years are gone, then and then your system will be slow and some of the periods are there, it's a neutral, it will be going to slow and slow, and then after the hardware devices are completely changeable. So that is a curve for wear out. So best example is when each and every day the hardware devices are newly came. For example, we can purchase 1 GB RAM and we can purchase 64 GB space in our mobile device. After 2 or 3 months or 6 months, it is wear out. Because of them, new technologies are came and new hardware devices are came with the help of 8 GB RAM or 1 TB hard disk space. That is possible with the help of, so that is a best example for failure rate for hardware. Failure rate for hardware, it's a high. So as we discuss failure rate of hardware, we just talk regarding them. Undiscovered defect will cause high failure rates early in the life of a program. However, these are corrected and then crown flatted as shown. However, the implications is clear. Software doesn't wear out. As changes are made, it is likely that some new defects will be introduced, causes the failure rate curve to spike. It is possible. Now, before the curve can return the original steady state failure rate, another changes is requested, causing the curve to spike again. Slowly, the minimum failure rate level being to rise, the software is deteriorating due to the change. Let's talk regarding idealized and actual failure curves for software. Before that software, we can just check out the hardware failure rate. Now in that system, we can just check out curve for software failure rates. On that same x-axis, that is a time, and y-axis, that is a failure rate, are there. And idealized curve, that is just like same as a hardware, but some of the difference are here. Whenever increase the failure rates due to the side effects, so changes are there in a software, we can update and we can use it. That is possible in software side. And an actual curve, it's work like just our heartbeat line, up and down with the help of actual curve. So this is your failure curves for software. Now third things, although the industry is moving towards component based assembly, most software continues to be custom built. The design engineer draw a simple segments of digital circuitry, does some fundamental analysis to assure that proper function will be achieved, and then goes to the shelf where catalog of digital components exist. As an engineering discipline evolves, a collection of standard design component is created. The reusable components have been created so that the engineer can concentrate on the truly innovative elements of the design. That is the part of the design that represents something new. So same thing in software basis, redesigns are there and it will be designed for better software and better for a custom built it. Well, types of software: system software, real-time software, business software, engineering and scientific software, embedded software, and artificial intelligence softwares are available. Internet software, software tools and case environments are available. Now let us talk regarding system software, a collection of program written to service other program at a system level. This is a best example for system software. A compiler or operating system, Windows 10 or Android, that is your system software, which we have to use for starting the system and ending the end of this system with the help of this operating system. So it is a most important part of system software. Next is real-time software, program that monitor, analyze, control real-world events as they occur. So that is called real-time software, or weather forecasting software. It's a real-time software. Next is business software. Program that access, analyze, and process business information. This is a business software. Next is engineering and scientific software. Software using number of crunching algorithm for different science and application, system simulations, computer aided design. It is useful for engineering. So this is a engineering side software. Next is embedded software. Embedded software resides in read-only memory and is used to control products and system for the consumer and industrial markets. It has very limited and historic function and control capability. So that is your embedded software. Artificial intelligence software, AI. Program make use of AI techniques and method to solve complex problem. Active area are expert system, pattern recognitions, games. It's the best example for artificial intelligence software. Next is internet software. Nowadays without internet, our days are not going. Programs that support internet access and their application. For example, search engine, browser, e-commerce software, authoring tools, WhatsApp, Facebook, Twitter, Instagram. That is the internet softwares are available in that market today. Software tools and case environment, tools and programs that help the construction of application of the software and system. So which is known as a case environment software tools. For example, test tools, versions control tools, etc. It is a part of software tools. After that introduction part of the software, let's talk just regarding a software engineering. It is the next unit for us. What is software engineering? Although hundreds of authors have developed personal definitions of software engineering, a definition proposal by Furtherview provides a basic definition of software engineering. Software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on a real machine. That is called software engineering. The IEEE 93 has developed a more comprehensive definition when it states the IEEE produce a software engineering definition is that software engineering, the application of a systematic, disciplined, quantifiable approach to the development, operation and maintenance of a software, that is the application of engineering to the software. And the study of approaches is in that regards of engineering. It is a part of software engineering. Thank you very much for watching my presentation of introduction part software engineering 1 unit number 1 SYBCA semester 3rd. Thank you once again.